Section 7.1, Verifying Trig Identities. So this box below gives us a couple techniques that we can use when we're verifying identities. We can write everything in terms of sine and cosine. We can use the Pythagorean identities we've learned before. We can factor. We can FOIL, distribute. Remember that when you do complex fractions, dividing is like multiplying by the reciprocal, and then we can always combine like terms and make a common denominator if we need to. So before we begin, just want to note that sine squared minus cosine squared we can factor, and the factoring method we're going to use is the difference of two squares. So this will become sine theta minus cosine theta times sine theta plus cosine theta. So this is the difference of two squares. So now when we have it to the fourth power, we can do this a similar method, but when we do this, we're going to now have sine squared theta plus cosine squared theta times sine squared theta minus cosine squared theta. So what we can do is factor it one more time, because this part right here is the part we just did. So then that means that my final answer is going to be sine squared theta plus cosine squared theta, because we can't simplify that anymore. But we can factor the subtraction problem with another difference of two squares into sine theta plus cosine theta and sine theta minus cosine of theta. So just note that while we go into our practice for today. So for our first one, now for each of these problems, there are different methods or different approaches that you could take. I might do something you don't see. You could do something and it still give you the same answer as long as each of your steps are supported by all the things that you have in the box at the top of your paper. So for problems number 1 through 6 for these notes, I'm just going to show you the way that I saw it, and then you can kind of match it with what you would come up with and see if your way works as well. So the first thing I'm going to do is distribute. And when I do that, I get cosecant x times cosine cubed x times tan x minus cosecant x sine x. And it's equal to the right-hand side. And I forgot to mention that I chose to work with the left side because that looks the more complex side. So the next thing that I see to do is to write everything in terms of sine and cosine. So cosecant is 1 over sine of x times cosine cubed is already in terms of cosine, so we're going to leave that alone. And then times tangent of x, which is sine x, over cosine x. And then subtract cosecant, which is 1 over sine, and then times sine x. Now we can go through and simplify. So all the way over on the right, our signs cancel out. And then on the left side, we have a sine over a sine, and we have a cosine cubed over cosine. So the cosine goes away, and then this is going to become cosine squared. So now let's write it all out and see what we have left. So we're left with cosine squared x minus 1. So now I hope that you notice we have something squared, So we're going to try, or we are going to use the Pythagorean identity. And cosine, now cosine squared x minus 1 isn't what we're going to adjust. We're just going to adjust cosine squared because cosine squared x minus 1 isn't a Pythagorean identity. It's really close, but we're just going to use cosine squared. So 1 minus sine squared of x equals cosine, and then I'm just going to add in that minus 1. And then if you notice, 1 minus 1 goes away, it adds to give you 0. So we are left with negative sine squared x, which is equal to our right-hand side, and we can stop there. Okay, so number 2. I am going to work with the left-hand side, so we're going to set it equal to the right-hand side because cosine is pretty simple, so we're going to try to work the left to be equal to cosine of x. And the first thing that I notice is that there is there's secant and sine and tangent next to each other, so I'm going to write it in terms of sine and cosine. And when I do that, I get, so secant's first, which is 1 over cosine of x, minus, and then sine stays sine, but then tangent is going to become sine x over cosine x, all equal to my right-hand side. So what I can do now is I can't simplify anything, but I have a left term and a right term, and they have the same denominator of cosine x, so I'm going to put this all together. And when I do that, I'm also going to multiply the sine times sine, which gives me 1 minus sine squared x all over cosine. Now, I hope that you noticed we have a Pythagorean identity, which is 1 minus sine squared, which is equal to cosine squared. So we have cosine squared over cosine of x equal to our right-hand side, and we have squared over 1, so we can simplify and divide out a cosine, and we are left with just 1 cosine in my numerator, which is equal to the right-hand side. And we are finished. Okay, so for number 3, I'm actually going to show you both ways. The first way, I'm going to work with the left-hand side, and then you can also work with the right-hand side as well. So right now, we're going to start on the left-hand side, and the first thing that I notice is that sine squared, so whenever you have something squared, you need to think of a Pythagorean identity, so that's what we're going to use first. So sine squared theta equals 1 minus cosine squared theta, and then we're going to multiply that by tangent squared theta, which is equal to my right-hand side. The next thing I'm going to do is distribute. And when I do this, I get tangent squared theta minus cosine squared theta times tangent squared theta. So what we ended up doing is taking a multiplication problem on the left and turning it into an addition problem of 2 terms. And if you look at the right-hand side, that's exactly what we have. And you'll also notice that right now, our first term is tangent squared, which is what it needs to be. So we just need to simplify that next term, and then we will be finished. So when I see cosine and tan next to each other, I think to write it in terms of sine and cosine, and then maybe we can simplify. So I'm going to have tangent squared theta minus cosine squared stays but times sine squared over cosine squared. So my cosine over cosine will simplify, leaving me with exactly what I need, which is tangent squared theta minus sine squared theta. Okay, so let's do the same problem, but look at the let's look at the right-hand side. So we're going to work with the right-hand side. So the first thing that I would do is write the right-hand side in terms of sine and cosine. And when I do that, so I'm going to have my left-hand side is equal to, so tangent squared turns into sine squared over cosine squared, and then minus sine squared. And then what I'm going to do is I'm actually going to factor. I'm going to factor out that sine squared. And when I do this, it's going to allow me to go from an addition problem to a multiplication problem. So you're left with 1 over cosine squared theta minus 1. The next step is to take the reciprocal. So I have my left-hand side equal to sine squared theta times, but 1 over cosine is secant. So I have secant squared minus 1. And now I notice that we have a Pythagorean identity. And when you look at that table that was given to you, secant squared theta minus 1 is equal to tangent squared, which is exactly what we needed. So number 4 to me sticks out that the left-hand side definitely looks more complicated. And since I have fractions and I have an addition problem, so I can put those together because that's where we need to go. If you look at the right-hand side into one term, I'm going to start by finding the common denominator. So for this first one, the common denominator is simply just going to be 1 minus sine A times 1 plus sine A. So this first term gets multiplied by 1 plus sine A on the top and the bottom. And then this second one gets multiplied by 1 minus sine A on the top and bottom. So I'm going to multiply those through, which just leaves me with 1 plus sine A plus 1 minus sine A all over both factors 1 plus sine A and 1 minus sine of A. Oh, I didn't add in my step. We multiplied. So now what I'm going to do is I'm going to simplify the numerator. So 1 and 1 gives me 2. And then I have sine A minus sine A, so I'm just left with 2. And then I'm going to distribute on the bottom. So I have 1 times 1, which is 1. And then I have minus sine A plus sine A, so those cancel. And then I'm left with minus sine squared of A. And again, on the bottom, we did double distribution or FOIL. So then, what we're going to do is there's a Pythagorean identity. And 1 minus sine squared actually equals cosine squared. And since we need cosine to become secant, which we can do because these are reciprocals. And we are left with 2 times secant squared A, which is exactly what we needed. Okay, so for number 5, we're going to deal with the left-hand side because that is clearly much more complex than 1. So the first step here would be, I'm going to write everything in terms of sine and cosine. And when I do that, tangent becomes sine over cosine. Cotangent becomes cosine over sine, all over secant, which is 1 over cosine, times cosecant, which is 1 over sine. So the next step is to find a common denominator. And this is referring to my numerator. So what I'm going to do is just kind of go back up and multiply. The common denominator is going to be cosine times sine. So all the way on the right, I need to multiply it by cosine theta over cosine theta. And on the left, I'm going to multiply it by sine theta over sine theta. Okay, so now we can skip down. So that gives me sine squared, so now I'm here, sine squared plus cosine squared all over sine times cosine. And this is just the numerator. So this whole thing is now all over 1 over cosine times sine. And I just multiply those two together. So there's a couple of things that I see going on here. The first thing that I would say I want to do is write this as a multiplication problem. So I'm going to write it as sine squared theta plus cosine squared theta all over sine times cosine. But now it's multiplying by the reciprocal, so times cosine times sine. And what do you notice? But these simplify. So now we are left with sine squared plus cosine squared, which you know, according to the Pythagorean identities, equals 1. Oh, I was supposed to be writing right-hand side this whole time. Sorry about that. So we're good. Okay, so this next one is definitely the hardest one on these worksheets. So I'm going to show you both ways. I'm going to work with the right-hand side first. And the very first thing I'm going to do is actually multiply it by the conjugate. So we have the left-hand side, which is equal to what we have on the right. And the conjugate, we're going to do the conjugate of the numerator so we can simplify that, because I need to get just cosine up there. So to do that, the conjugate, remember, it's the same. The first number is the same, but it's the sign in the middle, or the sign with the trig function that is different. So when we distribute, so if you notice on that numerator now the cosines are going to cancel, and I'm going to be left with 1 minus cosine squared of t. And then on the denominator, I'm going to actually leave it undistributed. And the reason why is because I have a tangent squared, so maybe this can help me either simplify it with cosine and sine, or maybe there's a Pythagorean identity coming. Not sure yet. So there actually is both a Pythagorean identity right here and and I'm actually going to do sine and cosine all in one step. So the numerator is where we have that Pythagorean identity. So my left-hand side is going to equal 1 minus cosine squared is sine squared all over. And then I'm going to change tangent squared into sine squared over cosine squared times 1 plus cosine of t. So now we can actually simplify the sign. They're being divided, and we are left then with 1 over cosine squared times t times 1 plus cosine t. So the next thing I'm going to do is I'm going to multiply the denominator, and I'm going to get 1 plus cosine t all over cosine squared t. Actually, what I'm going to do is I'm just going to distribute, and I'm going to write it separate, and you'll see why. So if I just distribute, I'm left with 1 over cosine squared t plus cosine t over cosine squared. So if you were to write it all over 1 and then separate it into this, that's fine too, but you can kind of do this all in one step. So what we can do now is we can simplify the cosines. So this is going to go away, and we're just going to have 1 on the denominator. So my left-hand side is equal to 1 over. Okay, so we're also going to do reciprocals here. And 1 over cosine squared is secant squared. And then you have plus 1 over cosine, which is secant. And from there, what I'm going to do is, I'm going to have to go over here now because I'm running out of room, is factor out a secant. And so since this secant t plus 1 is part of what I need in my solution, I'm going to actually just, instead of writing 1 over secant here, I'm going to do the reciprocal one more time and have my left-hand side equal to cosecant, or I'm sorry, cosine, because 1 over secant's cosine. So cosine t all over secant t plus 1. And that is what we were looking for. So I'm actually going to do the left-hand side also, and we're going to set it equal to the right-hand side. So let's take a look at what that is. So I'm going to do the same step and actually do the conjugate again. And that's going to look like this. I'm going to have, this is my original, or my left-hand side, cosine t over 1 plus secant t equal to now my right-hand side. So I'm going to multiply it by 1 minus secant over 1 minus secant. So then what I'm going to do is I'm going to distribute. I'm going to multiply the top and the bottom. And I'm going to have cosine t minus secant t times cosine t all over 1 minus secant squared. So now we're going to do the reciprocal because some things are going to be able to cancel. And I'm going to have cosine minus 1 over cosine times cosine. And then we also have the Pythagorean identity on the denominator. But it's a little different because instead of being a plus, we have a 1 minus secant squared. So this is actually going to equal negative tangent. So all over negative tangent squared. And that negative is going to come into handy because we have a subtraction problem maybe going on. Okay, so I can simplify my cosines here. So then I'm left with cosine t minus 1 all over negative tangent squared times t. So we are so close, except we have a negative tangent on the bottom and we actually have the opposite up top. We want cosine to be negative and 1 to be positive. So what we're going to do is we can factor out a negative on the top and the bottom. So if I take out a negative at the top, I'm left with negative cosine plus 1 over negative tangent. And a negative over a negative are going to simplify. And then I'm going to rearrange that top and write 1 minus cosine t over tangent squared, which is equal to my right-hand side. So again, just remember, you might have a different way of doing it, but as long as all of your steps are supported by the identities or even and odd or any of the things that we've talked about, especially on that chart that you're given, as long as they're supported by those, then you'll be fine. And if you get the same answer at the end, then that is acceptable too.